Okay, so we started recording, and I guess my first question: are you guys both okay to be recorded, even though it's just your voice?
Yeah, I'm fine with it.
Okay. So what we did last time is that's not it. Okay. So what we did last time was 1 second, I'm sorry. Hold on. Thank you. I don't want you to know, but thank you.
Should I leave it down here?
Should. Thank you, love. Okay. Okay, so what we did last time was we started from the very beginning, where we're trying to build up our intuition of, or we're trying to be very practical. So if we go to Excalibur, okay. So I guess, well, we started here, right? Where let's see here. And then it always takes me like a minute to get, into the teaching. So the way we are programming the robot is something called command-based programming. And I'm sure Aaron is familiar with it, but we're kind of going over the methodology behind command-based programming. And we're going to kind of like simulate the robot doing something from simulation. So I'm going to stop recording and then start over. So I think I'll do better that way. Let's see. Okay. So I've just restarted recording. I need to plug in my. Okay, and I think I'm okay. So how we program the robots is something called command-based programming. And so what that is you write about a series of commands which are high-level logic, which like is something you want the robot to do. So something that we, Raylia and I came up with is some different commands. Let's say for the drivetrain, it's like manually controlling the drivetrain. And another command could be, well, you want the robot to move in a path. For example, with a flywheel or a shooter, it's maybe like shooting the ball. And then what you can do is you can have more complicated commands. And so the example that we're kind of simulating right now is how to create a command to shoot the ball into an object into the goal. Okay. So we broke it down into different steps. The first step is to start the flywheel and then wait for the flywheel to be at its desired speed. Once that's done and it's at the right speed, you should start aiming to the target. And number 3 is you feed the ball into the flywheel, and then that shoots the ball. Okay, so this right here is a command. Okay, so a command represents higher level behavior of what you want the robot to actually do. Okay, then a trigger is something like, well, when do you want to run this command? Well, when it comes to a joystick like this, let's say when I press the A button, I want to start the sequence for shooting the ball. Okay, how things are structured is there's commands, which we just talked about. There's triggers, which we just talked about, which is when do you want to start running the command? And then this command needs to tell the subsystems how to actually, it needs to tell the subsystem, this is what I need you to do. And then the subsystem will then tell its motors or actuators to move. Okay? So what we did was we went over, so what we did is we created a controller, and we have this example, the sample flywheel subsystem, okay, just an example. And so what we're doing is we are creating right now, so as you see over here, see this says start flywheel and wait. So this command is a complex command, which you can write as a single command, and we have WPI lib. We have the documentation, which shows that, where is it? Command-based programming. Here, so we have commands, right? And then we can combine small commands to compose it to be larger or higher level commands. And that's what we're going to continue today. So right now, as of yesterday, we created a command called set flywheel to speed. So in this behavior, that's basically this right in here, okay? Start flywheel, wait for the flywheel to be at the desired speed, okay? And then what we did, so let me show this in action. So this is using the simulation. So I can run the simulation, and we'll see, I think, in the logs. Okay. And then we also have, we're going to start to use something called Advantage Scope, which is a logging software. Okay. So what we can do is, oh, maybe we're not there yet. So when I go to teleoperated, okay, and I press the A button, you'll see here, so in the code, right, I said driver controller, the A button, when it's true, okay, while it's true, we want to run this set flywheel to speed command, where we say, okay, I want it to go to 100, and then I'm passing in the flywheel. So the first thing you'll note here is that I'm defining the flywheel in the main robot container. And if a command needs to interact with the flywheel, we pass it in. Okay, so let's go into here. This is all recap. So what does this set flywheel to speed command do? What it does is, this is called, Raylia, do you remember what this is called? If this name is the same as this name?
I don't think I do.
That's okay. So this is called the constructor. Does that ring a bell from last time?
Yeah.
Okay, so could you potentially describe what the constructor does or when it's called?
The constructor is where you get to like write down or describe your variables.
Mm-hmm. So this is where you can initialize your variables, yeah, to default values, let's say. Okay, and this is called right when you call new set flywheel to speed command, okay? So over here, what we do, so this right here, now let's zoom into what a command is. Remember, a command is supposed to have the logic to tell subsystems what it should be doing. Okay. So let's see how it works. And remember, a command is made up of a few different methods. One is called initialize. This is run right when the command starts once. Okay. Then there's an execute method. This is called every 20 milliseconds. This is called again and again and again. Do you remember that?
Yeah.
And then there's an is finished method that's called to see if the command is finished. And then this is run at the end. So it goes like this, right? Let's see if there's like a picture. If not, then no. Okay. So it goes like this. A command, it goes like this. First, there's the initialize. Then there's the execute. Okay. So there's the initialize, then there's, once this is called, then execute is run every single time until the is finished. Goes like this. Execute is finished. If yes, no. If it's not finished, then this is run again. And then the end is called. So this is how a command works. First you initialize, then you keep running execute, and as long as it's not finished, you just keep going around in a circle. If it is, then you end it. Okay. Does that make sense?
Yes.
So we have initialize, execute, is finished, end. And so now, do you remember a critical thing I said last time, which is why aren't we putting anything in the execute? Do you remember that? So basically there's two ways. First of all, if a flywheel is at 0 RPM and you want it to go at 100, what is the logic for that?
We would have to increase it by a certain amount.
Yep. If your current speed is, let's say, 0 and your target speed is 100, what you do is you say, if the current speed is less than the target speed, you have to increase it.
Yeah.
If it's greater than, then you have to slow down, so you have to decrease it.
Yes.
Remember that?
Yes.
So why isn't that logic in this command here? And Aaron, I'd love for you to pitch in as well.
I mean, normally you just exclude stuff from execute if you don't want it to run more than once, but
Correct. Okay, so we're basically, what is this doing? This initialize. This is being run how many times and when?
it just once when this thing is called to.
Okay, and so what am I doing here?
Just setting the target speed.
Yeah. Okay, so why am I not doing the check in the execute method? This is empty. And as you can see, it still works. If I do B, See, it's doing that check,
Hmm.
and it's going down and up. This is something that's very important, which is continue.
I was gonna say, well, it's because it'll keep going as long as you're pressing the button for it.
So actually, if you see here, I'm pressing the button and then I stopped pressing the button. If you see here, see this flywheel at speed?
Mhm.
That's actually run
Yeah.
at the end. So if you see here, somewhere in the middle, I actually killed the function, or I killed the execution. Sorry,
Mhm.
I killed the command. So when I'm pressing the button, because remember, the button is while it's true, this is run. But when I let my finger off the button, then this command is stopped. So again, the question is,
Oh, is it because of interrupted?
no, so interrupted will be true. I can do like interrupted will be true if the command was not finished because this says is finished. If the trigger says, hey, watch, if I go like this and I click the A button, you see this interrupted is true?
Yeah.
That's because the trigger told it to stop running. So it was interrupted. And so you could put it in the execute method, but the way that we're going to program this robot is that a command should tell the subsystem what to do, and then it should ask the subsystem, are you done? But it should not be responsible for getting the subsystem to do what it wants, what you need it to. You should just issue commands, and then it should do it. So in the subsystem, you can use this periodic function, which will actually also run every 20 milliseconds. So every loop, this is where we're actually doing the logic. Does that make sense?
Yes.
Is that clear?
Yeah, I just wrote it down to remember.
Awesome. Perfect. Yeah, so so let's go take a step back because we're going to continue on this and then we're going to progress. Okay? So the logic is a trigger triggers a command. A command issues requests to the subsystems. Then the subsystems inside are responsible for making sure that their current state is at the target state. So the actual logic is happening in the subsystem. So really, the trigger is like, in one sentence, is telling the robot that you want to do something. The command defines what you want the robot to do. The command tells, like, it says, this subsystem, you should do this. This subsystem, you should do this. And the subsystem should say, oh, the command wanted me to do this, so I'm going to keep working until I'm there, until I've done it. Okay?
Okay.
Okay. So now, if you look here, I have this and then. So because, right, what we want to do right now is get this complex logic working, which is basically like for Auton, right? Once we get this command working, you can have an Auton command, which like drives to a location, and then shoots the ball. In order to shoot the ball, you don't have to say, oh, the flywheel needs to do this, right? You've already programmed that logic in. So the great thing about commands is that you can create simple commands, and then you can get more complex behavior by building off of those commands, those small commands. So this right here is the first command. Start flywheel, wait for the flywheel to be at the desired speed. That we've done. right? And all the command is doing is it on initialize, it says flywheel, go to this speed. And then it keeps checking, are you finished? And when the flywheel says, oh, I'm finished, then I'm done. Then this command ends. When this command ends, the next thing I want to do is aim. Okay. So for that, I created an aim command. So what does this look like in practice? If I open this up and I go to here and I go to, you see this? When it reaches 200, oh, oops. Hold on. Okay, when it reaches 100, it says flywheels at the speed. So, right, look at this. It says, is finished. Yes, I am finished. So then it went to the end and it said, the flywheel is at speed 100, which is what I wanted. And now I'm not interrupted, right? Because I'm actually, the flywheel told me it's ready. Oh, what happened? So, and when I did the and then aim command, so it went to the speed that it wanted to, and then it started aiming. Right, and you can just chain these along, right? So I'm going like this, and when it gets to the speed we want it to, start aiming. Does that make sense?
Yeah.
Okay. So there's this aiming logic, right? And then there's this feeding the ball into the flywheel. Okay. So it's the same kind of thing that you would do here, right? I'm not going to actually do it because it's the same kind of concept, which is start flywheel. So you basically, inside of this aim, maybe Raylia, you can say how I would code this aim command. What would I need to do?
You would have to create the class for it.
Okay, it's done.
And place whatever variables you have. And
Oops. What subsystems are actually required to aim?
the shooter, or you can move the drivetrain.
Okay, so drivetrain can be one. So if you have, yeah, you can do a drivetrain. Or what happened if you have, let's say, a turret, right? You can have a turret be responsible for for turning until it sees it, until it sees the target. So let's say you have a drivetrain, okay? Let's get rid of the turret example for a second. So how would okay, drivetrain, and what else?
A drivetrain.
So how would the robot actually know I'm at the right I'm at the right location?
Oh, you might need to use a sensor for it.
Mm-hmm. What kind of sensor usually would we need?
Pigeon.
Okay, so that's part of the drivetrain,
Yeah.
right? But oftentimes, in order for your robot to
would we need a Hall effect sensor to zero out like where you are, and then when you get to a certain angle?
Okay, a Hall effect sensor is senses magnetic fields. Remember, for like the elevator. A Hall effect sensor, if you put it, let's say right here, you could like make this go down, down, down until it touches, then it knows it's at the right location.
Oh, okay.
But usually, if you have a robot here, and you have like a ball, let's say, the target is like way over here, and the shooter goes like this. But in order for the robot to know where it should go, usually, what kind of sensor would we use? Like vision, maybe.
Yeah, I could use a limelight.
So we can use vision to like lock onto the target, and then we'll know, okay, we're at the right location, and then we can shoot. Does that make sense?
Yeah.
Okay. So what yeah.
In order to use a limelight, don't you need like markers to or like the tape?
Say that again?
For a limelight to work, like to go to a certain spot, you would need like the tape that reflects, right?
So yeah, either historically, there's been retro reflective tape where like on the target there's like tape that your limelight can see, oh okay, here's the target. It like shines a green light, and this reflects the light back, and from there you can like figure out where you are. Or there's these like April tags that FRC has started to use, where like you can like use like basically like a QR kind of scanner thing.
Yeah.
Okay.
What if that isn't provided?
If it's not, so vision will need either retro reflective tape or April tags. Okay. So so this is one way you can aim, right? Use the drivetrain and the vision. So how would you explain it in words, how you would get the drivetrain and vision to work together to aim to the target?
You could either have one of the subsystem or classes extend the other one.
Well, so they're separate subsystems.
Yeah.
And I would say like use vision to find the target. It should return how far off the target is from the center of the camera. Use the drivetrain to turn the robot to the right angle. This is how I would describe the steps for aiming. That kind of makes sense to me.
Okay.
Does that make sense?
That's what I would think. I mean, you'd probably like get a variable from the limelight that would like just track like how far off it is from the target, and then you'd feed that into the drivetrain, and it'll like keep providing power until it gets to that target. I guess it'd be a PID controller.
That's actually very important, right? Because so this was our shoot ball command, right? But to start flywheel and get it to the desired speed, how do you know how fast you should be going? How fast the flywheel should be going?
You don't use it as a variable?
Well, yeah, but like logically, the speed at which your flywheel should be going is dependent on where you are on the field. Right? Like if your robot is here, then your flywheel should be at some RPM. If it's way out here, it needs to be at a faster RPM. Does that make sense?
Yeah.
So how would you, so maybe what we need to do is we need to go back and rearrange these commands. Because maybe the first thing, this start flywheel, and wait it for it to be at the desired speed, maybe this needs to be augmented. Maybe this needs to use the flywheel subsystem, and maybe this also needs vision. Do you see what I'm saying?
Yeah.
Because maybe the vision will tell the flywheel, will tell this command how far I am from the field. And then the flywheel will then start spinning at the right speed. You see what I'm saying?
Yeah, but can't you also just go to the same spot each time?
Or you can go to the same spot each time, right? So you see how it's all about, these commands are really about you telling the subsystem, you telling the robot what it should do from a high level, right? Here we're talking about how the robot should actually get it done. We're not talking about, oh, you need to spin this motor and then use this camera. It's like high levels, you know, they're high level decisions. Does that make sense?
Yeah.
So what you could do is you could have aim, shoot ball from, I don't know, tower. This could be one command, right? Where you don't need vision because you go to the same spot every time. And here there's a known speed, like 2000 or whatever, I don't know, that you just say, okay, spin to 2000, and then that means you're at the correct speed. But then there could be shoot ball using vision. And this command, send backwards. Bring to front. So you can have shoot ball from tower. Okay, so we'll end the this part of the discussion with this. Shoot ball using vision, okay? So for example, shoot ball from tower would need to, well, you would manually drive to the tower. Then you would do set flywheel to speed, right? Then this would be like get distance to target from vision. This would be something like get distant, you know, and then this goes into here. Then from here, it's aim, and then it's feed ball into shooter. So you see, if you create let's say a command for feed ball into shooter, and you create the aim, and you create this command, this is easy to do, to create, and you can hook this up to a button. And if you want to use vision, what you would do is you would do shoot, you would get the distance to the target from a vision, and then that would feed into the same exact commands. You see how we can build commands from like building blocks?
Yeah.
You see that? Yeah?
Yeah.
Okay. So that's the first part of what I wanted to discuss. Now the question is, what's the next part that I want to discuss? I want to Are there any questions about this so far?
No. Oh, but hold on. I think I have a question.
Yeah.
All of this is autonomous, right?
This isn't. Well, maybe. So the thing is that this is a command, right?
Yeah.
And this can be a command that's triggered from a button, or this can be an auton mode. And all you do is you say, "Oh, this is the auton I want to use. This is a command. Now I want auton to run this command, so it'll run that command." You can take that same command and you can use it in Teleop.
All right. I have another question. So if I wanted to have a command, but instead of using a button, I would use a joystick. Would I just set a range of, like, if you go forward and it's like from degrees, like for example 90 to 120, then you move forward?
Say that one more time, please.
If I wanted to have a command, but the trigger would not be a button, but instead a joystick, would I just have like a range?
Yeah. So, what do you want? Do you have an example in mind?
Well, like if my subsystem was a drivetrain and
Yeah.
I wanted to, for example, okay, let's go backwards.
Mhm.
Would instead of pressing the button, I would use the joystick, right? So
Yeah.
would I describe that as a range of degrees of where I rotated the joystick? Or
I see what you're saying. Okay, so what you're saying is like a drive command.
Yeah.
That's what you want to do. Okay, so that's a great idea, and let's get that working. Okay. So what do we need to do? What are the inputs? Is this tank drive, or
Yeah.
is it
tank drive.
swerve?
It's a tank drive.
Okay. So how many parameters do you need for tank drive?
I am guessing 4
Like
for each.
how many joysticks do you need to get tank drive to work?
Oh, 2.
Yep. What are they going to be doing? What are each of the joysticks going to be doing?
One will go forward and backward, and the other will turn.
Okay. So basically there's actually 2 ways of controlling a tank drive robot. Okay, there's something called tank. What is it called? Import. Okay, so let's actually look in the documentation, okay? And differential drive right here, okay? So let's actually get a very basic tank drive to work. Okay. 1 second. Kinematics. Inside of differential drive, there's arcade drive. First dot drive. Where is it? It is called where is it? So tank drive is called differential drive, which means like it's like the differential between the difference in like the left speed versus the right speed will make it turn.
Yeah.
But there's actually two ways of doing it. One is, I'm not sure where it is right now. So you do need two joysticks. So option one is arcade drive. And let's look for arcade because I think arcade drive. Let's see here. So, robot differential drive. Oh, I don't really want that. Oh. Hey guys, can you go upstairs, please?
Yes, you're coming down. We want to watch.
You want to
The
watch?
iPad is off and
Please ask mommy. I'm on a call right now. Okay,
mommy
love?
said she can't
1 second.
give up.
Okay, sorry. So
Yeah, but mommy doesn't want me to talk to her.
okay,
I don't know.
let's see. EDU. Here we go.
Maybe I can't use it
There we go.
because I need to go on a television because mommy.
Yeah, I'll be right back. Hold on.
Because mommy.
Okay.
I'm back. Adam's
Okay.
gone.
Yeah, Adam said that he needs to do something.
Okay.
Okay. Are you here?
Yeah.
Okay, so I found it. And it's called here. So we need the kinematics, but so let's actually go to let's go to maybe what we can do is we can actually just so if you go up here, you can create a new project and you can do an example project, Java. So there's Tank Drive and then there's Arcade Drive. Arcade Drive is what you mentioned, which, oh, hold on. Let's look at Tank Drive, right? It's the easiest to understand. I'm gonna go to Documents, Tank Drive, and let's call this 4, Generate Project, Current Window. So let's actually look at how it's working, and then we'll, so if you go into Java, and the nice thing is all of these kind of look the same. So what they're doing, okay, they're using this thing. Okay, so let's look at what they do. So what they're doing is they take this differential drive. Okay, so what, where's the left? Oh, it's right there. Okay. So what they do is they create 2 joysticks. And then I guess there's already a differential drive like class where you pass in the motors, the left and the right motor. And then this will do it for you. But I don't really like that. Hold on. Here we go. This is what we want. Tank Drive inverse kinematics. But I thought they have, hold on. Kinematics, differential drive, kinematics. Two wheel speeds. Let's see. This isn't giving so much information. I mean, okay, fine. I mean, what we can do is we can kind of do it ourselves, and but it won't be like there's built-in ways to do this, but fine. Okay. So what we need to do, right? What we'll need to do is we need to get the Y axis of both joysticks. Okay, here we go. So if you look over here, you can, so Tank Drive is this joystick controls, if you go up and down, this controls the left side, and going up and down on this controls the right side. Okay, or you can do it so that up and down controls the forward, backwards of the robot, and then X and Y, this controls how much you're turning. You can do, those are both valid ways of getting Tank Drive to work.
Okay, got it.
Does that make sense?
Yeah.
So there's 2 ways of doing it. So let's do Tank Drive first, okay? So there is something called, so how would we do it? We're gonna have to create a command, right? This is gonna be called Tank Drive command, okay? So this Tank Drive command, what does it need? what does this command need? Remember, this is the overall logic that is needed.
We need to declare our variables
Okay, so for what?
for our drivetrain. So
So this is gonna need,
we would need the wheels, right?
so this is the tank drive command, right? What subsystems are required?
Drivetrain.
The drivetrain. What inputs? What are the steps? Okay. Nice. So the steps are get the y-axis of both joysticks, right?
Yeah.
And then what? When you have the y-axis of both joysticks, what do? What's the most simple way of getting this done?
I mean, you can manually test it out, but
At the end of the day, your tank drive command is going to have to tell the motors on the left and on the right side to go at a certain speed.
yes.
Right? So the most simple thing to do should tell left motor to move, and the right y-axis should tell the right motor to move. Okay?
Oh, okay, that's really straightforward.
Okay. So the tank drive command, well, what is that? So can be, well, it'll need the drivetrain subsystem. So we're going to need that. We're going to need to create that. We don't have that right now. We're going to need the left axis, right? And this is something that's really cool that I've seen, is they call it left supplier and the right supplier.
Why
This is
it
actually,
supplier?
huh?
Why is it supplier?
So this is something that's like here. So there is an abstraction called a supplier. And let's actually see how the supplier works. So left, because right, how would you send in the left value of the joystick and the right value of the joystick? Either you can pass in the joysticks, right? You can pass in the joysticks into this command. Like the command, you shouldn't really like pass in the joysticks, right? You could like create like something called a supplier, so that when you call this command, you can make it a joystick that tells the left how much to move and the right how much to move. I don't know. Does that kind of make sense in a way?
It's a bit confusing.
It's a little bit confusing. So where I came up with this is by looking at other people's code. So let's look at I'm taking a lot of like, they do some really cool stuff. So a lot of what we're doing here is we're looking at what other people do. And the good thing about programming is that if any team wants to reuse their code from last year to this year, they have to make it open source. So let's look at how they do drive with joysticks. You see that? They literally have a command called drive with joysticks.
Oh.
How do they do it? you see they have a supplier here.
Yeah.
So let's go into their code and where do they use drive with joysticks? Okay, so let's look into that. And so this right here, this is kind of like, there's a lot going on here. I don't really know what it's doing so much, but drive with joysticks, you see that? What they're doing is they're passing in the drive subsystem. And here they're passing in, this right here is called the supplier. So you see this driver, that's nothing more than, if you go up to here, where's driver? See this driver is just an Xbox controller? Command Xbox controller, that's exactly what we have. Command Xbox controller. So they call it driver, we call it drive controller. So let's actually see what they do. So they pass in the drive subsystem, and they pass in, like, this is called a supplier, where it just returns the X, the, you know, get left X. This is the joystick, this is the joystick, the left X joystick, and the right X joystick. Okay. And then their drive with joystick thing, they don't have to know that this comes from a joystick. They just like call this supplier and it gives them a double. It gives them a value from -1 to 1. So let's see how it works. And I understand it's okay. Here, let's call double supplier. Okay, so let's see. How does this work? I forget. So let's create a drive subsystem. And I think you can do something like this. So let's comment these out for now. I think you can do drive, let's say, so here we have to create a new drive subsystem like we did for the flywheel. And I think there's a command called drive subsystem dot set default command. Yeah. This is called tank drive command. Okay. So if you look here, you see that this, oops. Do you see that these two commands were triggered when this driver controller was clicked, when you clicked the A button?
Yeah.
But there's like, if you're driving, you're not gonna like click a button and then you're gonna start driving. You just want it to drive by default. Does that make sense? Like if the drive isn't doing anything right now, you can say set a default command.
Okay.
Okay. And then this tank drive command, what should it be doing? It needs a left supplier and a right supplier. So how do you do that? Let's see. Double supplier. Let's see. How does double supplier work? Let's see. Here's an example. This is how they do it. See this default drive right here?
Yeah.
This is their default command. So how does it work? So this is a command. Ignore the command base because this is from last year's code, but extends command, right? We have it as tank drive command. They call it default drive. Okay, these are both commands. What we're gonna need is the drive system and then the supplier for right here. They are doing arcade drive because they have rotation. But what are they doing? How do they make a double supplier? Right here. So this is how to create a double supplier. So what I have to do is I have to go in, do this like funny syntax where it's like that. And then this right here should be the, this is the what is this? This is the left supplier. Okay. So this right here is the left supplier and the right supplier. And this is getting the values from the left X, the left Y and the right Y. Does that part make sense?
Yeah.
Okay. So now, how do I make this tank drive command do what it needs to do? So first of all, I can do, so you said something which was very important, which is I have to save, remember, inside of this constructor, if I want it available in the rest of the command, I need to save it as a variable. Remember that?
Yes.
So drive subsystem, drive subsystem. A lot of times you'll see that if it's like if it's a member variable, people like calling it m underscore. I don't know why, but fine. We'll just do what everybody else does. Then what else do I have to save? The other
The
two.
suppliers?
Yeah. And so the type is double supplier, left supplier and right supplier. So what do I have to do in here in the constructor?
Initialize?
So I have to initialize. Basically, I need to, just like this set flywheel, what this constructor did is it saved everything that is saved the inputs into the constructor into the member variables. So I have to do that again. And so that's just m underscore drive is equal to drive subsystem. Do that and that. And that's what I have to do basically every time. Okay, every time in the constructor, if you don't want to lose these, you have to save them into a member variable. And now I have access to these suppliers in the execute. So what I can do right now is I can do the execute. Okay, so what I can do is I can say double. See that? So if I want to get the actual value from the joystick, I can just call supplier dot, and there's a function called get as double. So maybe this is a little bit more clear why a supplier might be a good idea. Because this command, you see that in this command, there's nothing that says, oh, this is a joystick. Like, oh, I get the value from a joystick. Because, for example, this is a great example. In autonomous mode, if I want to do tank drive, am I going to have a joystick that's actually sending the left and the right commands?
No.
I'm not. So if I put inside of here, get value of the Y from the joystick, this won't work. This command won't work for Auton. But if you abstract it and you say, What's coming in as a supplier, I don't really care how you get this number from -0 to -1 to 1, but I'm gonna say it's just abstract. It's a double supplier. When you call me, you have to tell me how I can get this double value. Is that a little more clear?
Yeah.
Okay. That was a hard question to answer because it's like, yeah. So, and then here it's saying, okay, execute. And here I'm putting I'm getting the left and the right values. So let's take a step back and see if this works. Okay. So just to recap. Oh, this is broken. Oh, because I need to pass in the drive subsystem. Okay. Can you tell me what this is doing? Or tell me what I just did, because a lot just went on.
Starting from the top.
From the top, from the root, which is the robot container.
All right.
How do we make it drive?
In order for it to drive, we would have to make or have two joysticks that control the left side and the right side of the tank truck. And we would need to get a left supplier and right supplier in order for it to give value back to us to get the y-axis of both sides. And we have to go into the syntax that we wrote. And then in the constructor, we have to save all those variables so that they can move forward.
Yeah, so I really liked that. How I would explain it is as follows. At the very beginning of when the robot starts up, it creates all the different subsystems it needs. It creates a drive subsystem. It creates a drive subsystem. Then inside of, you see this right here is the constructor, because the robot container is robot container. So this is run at the very beginning. This configure bindings thing is function is called. And this is like setting up everything that you need. It's setting up the triggers, and it's creating all of the commands, and it's hooking up all of the commands. What this set default command is doing is it's saying, if the drive system is not scheduled for another command, like if this right here were to be using the drive subsystem, stop doing this tank drive command. But if no other command is using the drive subsystem, then do this default command. That's what set default command means. It says the default command will be automatically scheduled when no other commands are scheduled that require the subsystem. So what I do is I want to do tank drive. Tank drive needs to know about the drive subsystem, because it's going to be telling the drive system what to do. And then it needs to know two parameters, which is how much on the left side it should go and how much on the right side it should go. And because I don't want my command to be bound to my joystick, I abstract it away as a supplier, such that whenever I do need a value, I can call get as double. And what it'll do is it will call this supplier and then get the value. In this case, it'll get the value from driver controller.getLeftY. So what this is going to do is, again, if there is an initialize, which there is, it should call start tank drive. And then every 20 milliseconds, it's going to call this function. What this function is doing is going to get the value of the left and the right. And I'm just printing it right now. But what I will be doing is I will be telling the drivetrain to go at this speed and at this speed. Is that clear?
Yes.
And so now what we're going to try to do is we're going to try to build everything to be compatible with the simulation. So let's see if it works. And again, I wish I had an actual joystick here, but I don't. But here is Teleop. And now I forget. So this is, you see this? If I do S, it goes 1, 0, 1, 0. Then I think this, if I go A there. So what I should be able to do, oh, what just happened? Oh, is there an issue? So here it actually crashed. And it said default commands must require their subsystem. So there's something that I haven't talked about called where is it? This add. Okay, let me just make sure this works before. Let's see, restart. Yeah, here we go. Okay, do you see this add requirements thing?
Yes.
So this is actually something that I left out kind of purposefully, but now it's actually needed. So, right, I'm trying to build up our intuition so we only get exposed to something as we need it. So you see this as set default command, which basically this is run if no other commands are using the drive subsystem.
Yes.
So inside of a command should tell the program what subsystems it requires. So you see this set flywheel to speed command. That's using the flywheel subsystem. It should be able to it needs to say, like if I go in here, set flywheel to speed, it should tell the underlying program that it's using the flywheel subsystem. So you do super dot add requirements fly sub, because the idea is that a flywheel cannot be used by two commands at the same time. Right? Set flywheel to speed command and set flywheel to 0 or stop flywheel command. Those are both going to tell the flywheel different things. So what we have to do is we have to tell the program that this command is using this flywheel subsystem. So over here in the drive subsystem, over here in the tank drive command, we have to tell it that it's requiring the drive subsystem. I don't know. That's something we have to do. So if I go over here and go to Teleop, you see here, this is printing out X, this is printing out the X and the Y. You see if I go like this, if I press the joystick, this number is changing.
Yeah.
If I press what is it seems like that's working by going W and D. This is when I wish I had an actual keyboard or an actual joystick. So I think axis 3. No. So I don't know which axis is for the right. So what I'm going to do is I'm going to stop this. And if I go to get right Y, you see this. This is 5. So what I need to do is when I run the simulation, I need my keyboard to have 5 different axes. Axis 5, T and G. So now if I go into Telia, you see this starts up right away because it's a default command. So you see here, now if I'm working on this, if I make this axis right here change, it's reflected over here. And if I do this axis right here, this changes, so that if I go like this, here's my 2 axes. You see that both numbers are changing?
Yeah, I see it.
Okay. So that's what this is doing right now. So first of all, you saw that this default command is running right away. Whereas these, the A button, like this set flywheel to speed command, is only triggered when I press the A button. Does that make sense? But this is right away. So what some teams actually do is, let's say they are driving around without a ball, and they want to then they pick up a ball, and then their flywheel is stopped. So then they say, okay, now I want to spin up my flywheel to the desired speed. But now it takes a while to get it there. So sometimes I've seen robots, what they do is the flywheel's default command is to go at like 100 RPM. So the whole time during the match, it's spinning at 100 RPM, so that when it gets a ball, it's already kind of started. It doesn't have to start from nothing. You see that?
Mm.
So that's a way. That's like a default command that the flywheel can do. How is this for you? Because it's a lot of information.
It is a lot, but it's really helpful. I mean, it's made like a few more things clearer, and I can see what I can do when I get back to school.
Yeah, really, a lot of what I know from this is just by looking at people's code. Like 6328. There's a lot that they're doing, right? Like this is like a lot of stuff. But it's like a combination of looking at other people's code, starting to like look into the documentation to see like what they're actually doing. And then like looking at documentation, and yeah, and then asking questions in the Discord. They have a Discord, which I talk to them a lot in. And so for example, this tank drive command, all it needs to do now to get the robot to move is to call mdrive.tankdrive, And then what do you want to pass into it? Left and right. And then all we have to do is we have to tell the tank drive tank drive. Nice. Okay, so this is the tank drive function. So now this is happy, right? And then we actually do need this execute. And this is all. Right now the tank drive is now responsible for making this tank drive work. So inside of here, it has like Talon. No, what motor controllers are we using? Falcon? No?
I think it's called Talon FX.
Talon FX? I think so. Here. Phoenix Pro API. Let's see, Talon FX. Yeah. So all we'll do is, oh, wait. Inside of here, the drive subsystem, Talon FX. Oh, we don't have it.
Yeah, you don't have the library. You have to get
So
it separately.
Yeah, so installing Phoenix 6, installing API, job, okay. I don't want to, where is the, Phoenix 6, installing API, what is it? You have to actually install it here, right here. So you have to go here. You have to go here. Install.
You can search like a
suppose.
library or something.
Yeah. Yeah.
Manage vendor.
Manage vendor. Install new libraries online. You paste that in. Okay. Spec. This is the 2023 version. So we need the 2024 version. So where is it again? Phoenix. (2024). Here. It's this.
No, is it?
What? Hold on.
So the library already installed in the bottom right corner.
Say that again.
So the library already installed, which is weird. Because it usually doesn't come installed with WPI Lab.
So if I do inside of drive subsystem, if I do Talon FX, no. Because they have quite a lot of cool things. Look, here's the bro. Phoenix 6. Let's go to features. Talent FX. No, not hardware. Let's go to maybe. No, that's just device specific. Here. Talent FX. Open loop control. Diff drive. This is, yeah, here. So this is how 6328, they have like a sample project which has Talent FX. They get it from here. So
Where'd he go?
I don't know. Maybe his computer crashed. Or maybe he's downloading something.
Okay.
How's your break?
It's been okay. I think not much has really happened. I don't know. It's been fine. How did finals go for you?
Oh, they were alright.
How was your POL?
Oh, I have to do it again.
Oh, that's fine.
Yeah, but I'm probably gonna have to do it before Houston.
Oh,
sorry about that.
well, good luck with that.
Thank you.
Okay, are you here?
Yeah, we're here.
Okay, so I found something is called,
I mean, it's weird that it says it has the libraries.
oh, so what I actually did is I went to here. You can actually uninstall it. So I uninstalled, and now I need to reinstall the new one. So CTRE Phoenix 2024. Okay. Here.
I mean, this is the
Yeah.
import I use for the actual code.
It changed this year.
Did it?
But yeah, they have some very cool stuff actually, and I'll show you. Here, this should work because it's the newest version. Yeah, here we go. Okay, so let's actually go over the API if that's fine by you, because a lot of things have changed. So do you see here, Talent FX?
Mm-hmm.
Okay, first of all, it installed. Yeah, so it's all working now. Let's actually just take a look at their documentation, and then let's take a look at here how this works. Let's go to, I think they have a flywheel in here. Okay. So how you create a Talon FX controller is like this. You do, and Rayleigh, are you here?
Yes.
This might look familiar. Talon FX, this is the name, leader, equals new Talon FX. Does this look familiar? Where this right here and this right here, and there's a new command.
Yeah.
So what is this right here? And what
That's
you
the
pass
port.
into it? Yep, the port. And then, Aaron, something that you're, okay, so we'll ignore this for a second. So here, let's actually, okay, open loop control. This is like if you want to drive, you do like a drivetrain or something, okay? What they do is they have something called, I think they call them requests, or here, API usage, API overview. Okay. So there's different, a few different, what's it called? Terms in the Phoenix 6 API. There's something called configs, like configuration, controls, signals, and then sim. So let's go over it. Let's actually just skip that for now. So a control request, okay? So if you want the motor to, let's say, go at a certain RPM or sorry. If you want the motor, hold on, sorry. Let's take a step back. There's different types of controls. There's something called duty cycle. Hold on, let me go to hardware specific. Where is it? Device specific. Here. Open loop control. So there's something called, where are all of them? Here, perfect. Introduction to controlling a Talon FX. There's a variety of open loop and closed loop control requests. Open loop means like you're telling it what voltage to go at or something, whereas closed loop is like for PID. If you want to get like an arm to a certain angle, or if you want to get a flywheel to a certain speed, the library will actually handle it for you, which is really, really cool. So Aaron, there's no more, you don't have to, like for PID, you actually don't need anything else but you only need this library. You still have to set the P, the I, and the D, but it'll do it for you once you give it the parameters, which is cool. So let's look at duty cycle, okay? Again, these are the output types. Duty cycle outputs a proportion of the supply voltage, which ranges from -1 to 1. So remember, Rayleigh, over here, the drive subsystem, where is it? You see here, this tank drive, this left and right went from -1 to 1.
Yeah.
So all we have to do is create a duty cycle So let's actually do it. Let's do Talon FX, left motor, right motor. Inside of here, let's just say a left motor is equal to that, right motor is equal to that, okay? Now you can say, okay, I want the left motor to go at whatever this left is. Okay, like 2 minutes or a few minutes. So what I can do is I can type in set control. Okay. You see this set control thing?
Yes.
And then I can use this duty cycle control. So let's do that here. So duty cycle control, I can do something like oh, I think it's called duty cycle out. Okay. So you see this right here, this 0?
Yeah.
I can just pass that in here. And this I can rename left duty cycle. And I can do this right duty cycle. Okay. And then just like that. And this will actually get the robot to go at those speeds. Okay. Let's look at this example. See this left request?
Yeah.
And right request, they're 0. Here is get the joystick inputs, so forward and turn. Then this is their little logic to like get it to be, but ours is just left and right because ours is Tink drive. This right here is arcade drive. And look, left leader dot set control, left motor set control. Then they do left request with output left out. The reason why they do that is this left request here is set to 0, but they can like override it with this with output. This left out is here. So what we can do is we can say duty cycle out left, and we can do left duty cycle. Duty cycle right. And you can actually do this. And then over here, you just do left duty cycle dot with output left. Just like that. That's how you can get a robot to run. Does that make sense?
Yeah.
So this right here is a drivetrain that'll run.
Okay, got it.
Okay, I guess we'll stop here. But I think we covered a lot so far.
Yeah.
So I guess what we did today that's new is we started working on a new drive, on a new command to make the drive system work. Okay. Well, I hope that was helpful. And I think we're scheduled to do one more tomorrow.
Yeah.
And maybe
Yeah.
tomorrow. So tomorrow, my goal is as follows, just to give some. I don't know if it's a little too complicated or not, but this is what I want to kind of do is 6328 has like an amazing way of
No, any second.
okay. So we'll continue tomorrow.
Thank
Okay.
you. Bye.
Thank you.
Bye.